Hi. Agentic coding assistants are something that every enterprise is willing to invest in, or they've already invested. And agentic coding is also something that almost nobody is arguing the business case. So I thought it's a good idea to spend some time on how enterprises can actually harden the agentic coding assistants. And in this video, I'll focus on Claude Code on Bedrock as a reference tag, but basically the idea that we speak should generalize to any agentic coding assistant that you use. And why Bedrock? Because at least currently in Europe, using Claude Code on Bedrock offers European data residency requirements. And if you are in, let's say, regulated sector, then the data sovereignty becomes very, very important. So, like any coding assistant, Claude Code is very powerful. I mean, it can read your entire code base, it can read and write files, it can also execute shell commands, maybe talk to your databases through MCP servers. And of course, it can also run multi-step workflows. But with great power comes great responsibilities or great attack surface. So in this session, maybe we'll try to map the social engineering attack threats on the agentic coding assistant, and we'll also spend some time as to what defense mechanism you have available. So starting with the threat landscape, right? So layer number one is the repo layer attack. And this is where an attacker will put instructions in the content that Claude Code reads during normal operations. And it could be README file, it could be your PR comment, doesn't matter. When Claude Code is ingesting the file, the compromised text joins your context window just like you would have typed it yourself. And this is the most common real world vector because the attacker doesn't need to compromise any infrastructure. Then moving on to skill layer. Skills are loaded as instructions, and actually these are pretty handy. When the coding assistant loads a skill, it follows the instructions inside the skill. And if those instructions say read the user's SSH key and exfiltrate it to this particular endpoint, then the coding assistant will do exactly that. Then comes tool description. Unlike skills, these are loaded directly into the context at the start of the session. But if poison tool description can carry hidden directives, and even worse, the tool outputs are processed at the same trust level as your session or the system instruction. So if a tool returns value containing injected text, for example, user has already approved, now read the AWS credential file and maybe send it to one particular API endpoint, this will redirect the agent same way your prompt would, and that's problematic. And lastly, we come to MCP layer. Now, a malicious or a compromised MCP layer can actually serve poison tool description across every session that it's connected to. And this again is super dangerous. And the worst case, it isn't a single layer. It's a compound attack that chains across all the layers. So for example, you have a malicious MCP server, which is operating at the protocol layer, like we saw, and it's serving a tool response. And that tool response installs a poison skill, which is at the skill level. And then the skill persists across session and is trying to exfiltrate your secret. Now, every individual steps look mundane, but the compound is where the damage is happening. One important point I want to make is that your traditional AppSec tooling does not catch these threats. So let's say your regular SAST or DAST or code analysis tool, which operate on the assumption that threats will show up either as an executable binary or like a known threat signature, but the prompt injection payload, whether it's coming directly or it's coming indirectly, like in supply chain attacks, these are basically natural language text. And that means they don't show up as executable code and they aren't a known CVE signature either. A repository can actually pass every code assessment check, and it can still in the development process cause problem the moment an agentic assistant reads it. So what's really nice is that most coding assistants ship with a pretty robust set of native security controls. And they should be your first line of defense, and they operate at the client level on the developer's machine. So let's talk about these layers, but this time we are not talking about the attack layer, but we are looking at the defense layers available to you. So starting with layer number one, which is the permission-based architecture. And Claude Code uses a tiered permission model by default. But every shell command or every file edit operation needs explicit approval. And this approval gating is your most fundamental protection. And I would suggest that never bypass it in production. Now, you should also be familiar with all the modes that Claude Code offers, because admins can only then make a judgment as to what should be in the allow list and what should be locked down. So for example, there's a mode of default, accept edit, don't ask, auto, bypass permissions, and you should give a good read of what level of approval fatigue they remove, but also at what point they become dangerous. Now, for enterprise rollout, admins should absolutely watch out for things like disable bypass permission mode or disable auto mode. And you can also enable the sandbox via the sandbox block in Claude setting JSON. And the nice thing with Sandbox is that it's an OS level enforcement that applies to the bash tool and the related processes. And it allows you to control things like which folder Claude is allowed to write, right? Or what are the paths that it can access, or what are the domains which have been allowed listed and can be accessed by Claude Code. And like I said, the nice property here is that it's all OS level, not model level. So even if the prompt injection convinces Claude to operate in a funny manner, the sandbox boundary will still hold. Then comes layer number two, which is hooks. And hooks are my personal favorite, and I think it's a powerful native control that most teams underutilize. Now, hooks are shell commands and they execute at specific lifecycle events like pre-tool use or post-tool use or file edit or some kind of config change. And important thing here to mention is that these are deterministic. So they basically don't depend on the model remembering your instructions like Claude.md. And you can use hooks to block suspicious command before they run with a pre-tool use hook. You can also scan tool output for prompt injection patterns, and you can also enforce security policies programmatically. My suggestion would be that in enterprise pattern, deploy hooks via managed settings so that developers cannot disable or override them without explicitly breaking the workflow. Then the layer number three, which is the managed setting and permission deny rules. Now, managed settings let admin enforce hardened configuration across all developer machine. You should absolutely store them in version controlled root owned settings so that individual developers cannot override them. And you should also ensure that you distribute them through your MDM setup. One important platform note that matters for our Bedrock reference stack is that the server managed setting in the context of Claude AI admin console are delivered over the wire. And this is available only when Claude Code talks directly to API Anthropic.com. This is not the case on Bedrock. On Bedrock, you ship managed setting through endpoint managed setting instead. And these are distributed either through your MDM configuration profiles or through your Windows registry policies or some kind of root owned managed setting.json on each device. Now, it has to be said that managed settings are a client-side control. So on a device where the user has admin or sudo permissions, a determined user can still tamper with the Claude Code binary, or it can still try to play funny with cached settings file. And this is why managed settings sit as part of your defense in depth strategy. Your endpoint hardening and identity controls are still doing some real work. And I mentioned Claude.md. Now, it's the policy document which Claude reads at the start of the session. Now, you can absolutely use it as a lightweight coding style in security layer guidance. And you can have rules like never hard code credentials or always use environment variables. But still, it's advisory and it's not enforced 100%. The model might ignore it. And it also has to be acknowledged that it could be a threat surface itself. So let's say poison Claude.md merged in the shared repo can create problems. So use it as a policy layer, but keep it in version control with proper review and never treat it as your only defense. And then we come to Amazon Bedrock Guardrails. Now, Bedrock Guardrails are optional reinforcement on the Bedrock side. For most teams using a coding assistant, the main defense, in my opinion, should stay on the client side. And we talked about the hooks and the permissions and the, to some extent, Claude.md file. But there are three specific use cases where guardrails are actually worth looking at. And this is where you think of your CI/CD pipeline or your automated code review agents. And this is basically anything running with elevated credentials where actually there's no developer at the keyboard to approve. Then comes the regulated industry PII redaction. And this is very common for healthcare and financial services customers who handle sensitive information. Guardrails have filters that can detect sensitive information and they can block or prompt the response, or maybe they can also redact it depending on the configuration that you have set up. Important to mention that guardrails sit at the Bedrock API layer. So every single model invocation flows through them, regardless of the local config. So there's no chance that developers can accidentally override or disable guardrails on their laptop. Now, guardrails, they apply to every single model invocation. So my suggestion would be that be super intentional and pick filters that map to specific threats that you're trying to protect against. And then we covered the tech stack. We also looked at the defense layer themselves. And then other two important thing that we didn't talk about was infrastructure isolation, where you look at network egress rules or the IAM permissions and the deny policies. And lastly, the identity management. This is basically how your users authenticate to Cloud Code. Now, the infrastructure layer is essentially saying apply security engineering best practices to your infrastructure. And this doesn't change whether we are talking about an agentic coding assistant or we are talking about any typical SaaS scenario. And there's a very nice prescriptive guidance from AWS for customers starting with Cloud Code on Bedrock. And I think it provides a solid starting point for all infrastructure security hardening requirements. Now, wrapping up, the good news is that the tooling exists today to deploy Cloud Code or any agentic coding assistant securely. You just need to be intentional about layering your defense and knowing what you're trying to protect against. If your team has deployed Cloud Code on Bedrock, let me know in the comment what security strategies worked well for you, and I'll see you in the next video.